Next is question number 81, which says that if fx is equal to a into cos of x minus 1 plus sin x when x is less than 1, and this is equal to 2 when x is equal to 1, and this is equal to b into x square minus 1 upon root x minus 1 when x is greater than 1, and limit of x tending to 1 fx is equal to f1, then greatest integer of a plus b is, right. Now it is given that limit x tending to 1 plus fx is equal to f of 1 is equal to limit of x tending to 1 minus fx, right. So we can say that for the third function, this can be written as limit of x tending to 1 plus b into x square minus 1 can be written as x plus 1 into x minus 1, and x minus 1 can again be written as root x minus 1 into root x plus 1 upon root x minus 1. So this is equal to f of 1, that is equal to 2. So this is again equal to limit of x tending to 1 minus, that is limit x tending to 1 minus a into cos of x minus 1 plus sin x, right. So solving this further, it can be written as these two will get cancelled, so x can be put directly here. So we will get 4 times b is equal to 2 is equal to, putting x equal to 1 here, we will get a into cos 0, that is a plus sine of 1, right. So from here we get the value of a plus b equal to, a is equal to 2 minus sine 1 plus b is equal to 2 by 4, that is 1 by 2, right. Now we have to find the value of greatest integer of this value, right. Now it can be rewritten as 2 plus half can be written as sine 30 degrees minus sine of 1 radian is approximately equal to 57 degrees, right. So this is what we get from here. Now from the graph of sine x, we can observe that here we have 30 degrees and here we have 57 degrees. So the value of sine 57 is definitely greater than the value of sine 30, right. So this value is something lower than 2. So we can say that the value of greatest integer of a plus b is 1, right. So the correct answer will be option number 2. Next is question number 82, which says that if complex numbers z1, z2, z3 and z4 represent the vertices ABC and centroid of an equilateral triangle ABC respectively, then which of the following is incorrect? Now for an equilateral triangle ABC which are having vertices z1, z2 and z3, we know that z1 square plus z2 square plus z3 square is equal to z1 z2 plus z2 z3 plus z3 z1, right. Also we know that z1 plus z2 plus z3 whole square is equal to z1 square plus z2 square plus z3 square plus 2 times z1 z2 plus z2 z3 plus z3 z1, whose value can be substituted from equation 1 as z1 square plus z2 square plus z3 square, right. So this is equal to 3 times z1 square plus z2 square plus z3 square, right. So this is the second equation that we get. Also it is given that the triangle ABC has z4 as centroid. So we can say that z4 is equal to, centroid is z1 plus z2 plus z3 upon 3, right. This is the centroid. Hence from this we can directly see that the option 1 is correct, right. Now to check the rest of the options, let us find the value of z4 square, right. z4 square will be equal to z1 plus z2 plus z3 whole square, right, which can be put from equation 2 as 3 times z1 square plus z2 square plus z3 square. Cancelling 3, we will get this equation which is given in option number 2. So option number 2 is also correct. Now, converting this equation as given in equation 3, we can write it as, from equation 1, we can put it as Z1 Z2 plus Z2 Z3 plus Z3 Z1 upon 3, right? Now, this is given in option number 3, so this is also correct. But nothing of the form that is given in option number 4 can be obtained, right? So the correct answer is option number 4. Next is question number 83. Which of the following is incorrect? 4 statements are given and we have to check which one is incorrect, right? Now let us go one by one. So first option says negation of P and Q, right? So this can be written as negation P or negation Q, right? So this is correct. Let's go to the second option, that is negation of P or Q. This can be written as negation P and negation Q. So this option is also correct. Now, third option says that P is to Q can be written as negation P or Q, right? Similarly, negation Q to negation P, this can be written as Q or negation P, right? Now, as these two are equal, so these two are also equal. So this is also correct. Now, let us look at the fourth option. Fourth option says that negation of P to Q. So this can be written as negation of P to Q and Q to P, right? Now this can be further written as negation of P to Q or negation of Q to P, right? So this is equivalent to negation of P to Q is written as P negation P or Q, or negation of Q to P can be written as negation Q or P, right? So this is equivalent to P and negation Q or Q and negation P. But in the given statement here, and is given, so this one is false. So option number 4 is the incorrect statement. Next is question number 84, which says that the direction ratios of two lines are 1 minus 2 minus 2 and 0 to 1. The direction cosines of a line which is perpendicular to the above lines may be. Let us assume the direction cosines of the required line as L, M, N. Now, as this line is perpendicular to this one, so we can say that L into 1 minus 2M minus 2N is equal to 0. Also, this line is perpendicular to this line, so we can say that L into 0 plus 2 into M plus 1 into N is equal to 0, right? Now, from here we can see that L upon minus 2 plus 4 is equal to M upon 0 minus 1 is equal to N upon 2 minus 0. That is, L upon 2 is equal to M upon minus 1 is equal to N upon 2. So the direction cosines can be 2 upon 3, minus 1 upon 3 and 2 upon 3, right? So the correct answer is option number 4. Next is question number 85, which says that the value of limit x tending to pi by 2 tan square x into under root of 2 into sine square x plus sine x plus 1 minus under root of sine square x plus 4 sine x minus 1 is. Now these type of questions can be solved by rationalization. So this can be written as limit x tending to pi by 2 into tan square x into multiplying and dividing by under root 2 sine square x plus sine x plus 1 plus under root sine square x plus 4 sine x minus 1. In the numerator we will get a plus b into a minus b, that is a square minus b square, that is 2 sine square x plus sin x plus 1 minus sin square x plus 4 sin x minus 1. So this will give us sin square x plus 1 minus 4, that is minus 3 times sin x plus 1 minus of minus 1, that is plus 2 upon under root of 2 into sin square x plus sin x plus 1 plus under root of sin square x plus 4 sin x minus 1. Right? Now here it can be further written as limit x tending to pi by 2. Tan square x can be written as sin square x upon cos square x. Cos square x can be written as 1 minus sin square x. Making its factors, it can be written as 1 minus sin x into 1 plus sin x. Similarly, we can make the factors of this quadratic in sin x. So it can be written as sin x minus 1 into sin x minus 2, right? And in the denominator we have 2 into sin square x plus sin x plus 1 plus under root of sin square x plus 4 into sin x minus 1, right? Now, these two can be cancelled with minus sign, right? So, applying the minus sign here. Now, putting the limit x tending to pi by 2, we will get minus of 1 into 1 minus 2, that is minus 1 upon, in the denominator we will get 1 plus 1, that is 2 into, in the under root we will get 2 plus 1 plus 1, that is 4 under root, that is 2 plus 1 plus 4 minus 1, that is under root 4, that is again 2. So this is equal to 1 upon 8, right?